Board, everyone. This is Joe Holbrook. I'm a cloud architect, developer, and instructor. And I'm really excited to be talking about the top 12 Kubernetes Security Best Practices for 2020. As far as best practices are concerned, there's a lot out there around Kubernetes. So what I've done is I put together a list of the top 12 areas that I typically see clients and students sort of not really attend to as well as we would like to see. Generally, what I want to go through is to go through the areas that your company could prospectively improve upon in the next year ahead. Before we get started, though, let me do a quick introduction. My name's Joseph Holbrook, and I've been a cloud and blockchain architect for many years. And I've been working on numerous cloud platforms, such as Google Cloud and AWS. I'm also a published author as well, and a prior US Navy veteran. By the end of this webinar, what I hope you're going to be able to understand and take away and bring back to your organizations are 12 of the more important security best practices in Kubernetes. Now, there's probably well over 200 documented different best practices. What I've done is I put together basically 12 that I think really could use the improvement. So that's what I'm going to focus on. I'll also talk about some areas of confusion because a lot of the best practices are not just container focused, but they're focused on DevOps, cloud native, and SRE. Now, SRE is site recovery engineering. And we have to be able to bring everything together to increase our security posture. I'm also going to talk about DevSecOps and why you might want to know about that as well. It's sort of a sub area of DevOps. And then we'll get into the top 12. And then I'll talk about resources about where you can find out more about the resources available on Kubernetes, but also about resources available on Quick Start. Now, oh, Jesus. Okay, I'm going to start over, guys. I'm sorry. It looked like I didn't start the recording. Okay. Let me go ahead and record. Okay.
Can you turn on your webcam also?
Yes.
Thank you.
It says the host has stopped it.
The host has stopped
The video.
Really?
Uh-huh.
Just a second. Try now.
Hold on now. Oh, something happened there. Kicked off my security software. All right, let me try it now. There it is. Okay.
Yeah.
All right, let me go ahead and see that? Looks like it's okay.
Yeah, it's fine.
Okay.
Great.
All right. All right, so I'm going to go ahead and start over. All right, ready to go? Now let me check the recording. And okay. Welcome to the top 12 Kubernetes security best practices for 2020 here on Quick Start. Let's go ahead and talk about a quick introduction before we get started. My name is Joseph Holbrook, and I've been a cloud architect, a blockchain architect for quite a while. I'm also well-versed in the different cloud platforms as well. And I'm really looking forward to talking about the top 12 areas of Kubernetes. Now, being in the cloud, being in the technology world, containers is one of those areas that we really need to get into and focus on and deploy our software, our code, in a professional, prompt, and secure manner. And lastly, as far as an introduction, I'm a widely known course author. I also have a book out called Architecting Enterprise Blockchain Solutions, and I'm a prior Navy veteran. So what are we going to learn in this event? We're going to go ahead and understand the top 12 Kubernetes security best practices. We want to know how DevOps, cloud native, and SRE best practices can work together to enhance our security posture. We then want to know what Dev Security Ops is and why it's important to understand. We will then focus on the best practices at the end. We'll go through each of the top 10 or top 12 best practices one by one. And then I'm going to focus on resources to find out more information. So let's talk about defining what DevOps, cloud native, and SRE is. Because if we're going to implement basically a secure container environment, it's more than just about taking care of Kubernetes. It's really an all-encompassing IT event in itself. We need to have development, we need to have operations involved as well to ensure that we have our deployments in Kubernetes as secure as possible. It also will require probably some assistance from your IT security group as well. That's assuming that they're even familiar with containers. Now, that's one weakness I do find in organizations, is that typically IT security is pretty, what I would call, lacking in the knowledge of containers. They know VMs, but they don't really know containers. So I'll focus on some areas that we could really take to production, hopefully down the road. Now, let's talk about DevOps, cloud native, and site recovery. The first thing is what is DevOps? So DevOps is really development and operations working together in an agile relationship. Typically from a historical perspective, development, operations, they didn't really work together. They sort of were separate and they had their own organization. So we want to be aware that development and operations should be communicating with each other, working together, and also too, it should be on a level playing field. Typically what can happen in some organizations, development and operations sometimes will take over the leadership role. And we really need to have an eye-to-eye and not so much a looking up or looking down approach. Now, DevOps is really a change to the relationship. And that's going to be really important. We'll find out why here when we get to the top 10, for example, top 12, I should say. Now, when we're deploying our pipeline, some terms I'll be using quite a bit just to define them will be continuous integration, continuous delivery, and continuous deployment. We want to be aware that when we deploy our main lines, that we're generally going to be using containers and our builds are going to be in a workflow. That workflow needs to be secure as well. There's vulnerabilities that could be induced from our repository to our build process to our production processes as well. So it's an all-encompassing manner in the top 12 list, and we will find that out as well. All right, now, as far as the 4 axes of DevOps, again, it's more about the culture. Processes are really big here. It's one thing when we deploy our workflows or containers or mainlines and pipelines, basically. We need to make sure that we have the right process in place. We don't just kick off a build without actually scanning the Git, or we're not actually looking at a repository appropriately. Also, too, when we're getting ready to deploy to production, we probably need to do what? We need to look at how we're going to secure our containers. We want to make sure that they're versioned. We want to make sure that the build process as part of that is secure, that permissioning is correct. Perhaps some developers should have access to certain builds, but others maybe should not. So it's role-based access control is the focus area. We're going to talk about that. It's one of our line items that we're going to talk about. All right, now, organizations and DevOps. So organizations that employ continuous deployment, for example, really should benefit from processes around feedback. Feedback is absolutely critical to a secure environment. If you don't let people know something's wrong, then down the pipeline, people may not be aware of that. So the value comes in with automation, and automation really shouldn't happen though until we have our processes in place, etc. And again, it's all about having that workflow secure with our container environment. We should also consider integrating our SRE or DevOps teams, for example. Now, when it comes to IT management, we want to enable a build once policy. Well, why would that be important? Because when we deploy a pipeline, later phases of the pipeline, the main line, should have a consistent build. So when we get to step 1, step 2, and step 3, we want to make sure the consistency is there. Having multiple configs, different cluster management processes really could be really confusing. So minimize that. Look at integrating SRE and DevOps. What about cloud native? So cloud native is a term that seems to be used more and more. And it actually does have some value to how we deploy our applications in the cloud. Now, if you're using Kubernetes on-prem, this may not be so important, but if you're deploying Kubernetes in Amazon or in Google Cloud or Azure, then we really need to consider cloud native. Cloud native is a development term. It's used to describe container-based environments, but it's also used on how we deploy our applications, how we package the applications into containers and deploy them as services to the cloud. And it really provides agility, and I think that's the main point we want to focus on. And then lastly, as far as a term we want to define is SRE. Now, SRE is site recovery engineering. When it comes to site recovery engineering, it creates a bridge between development and operations. Now, this is similar to DevOps, however, there's some differences that are added to it. The focus with SRE is on software engineering, but also with availability, latency, performance, etc. It's about responding to the performance, the availability, the change of that application that is being deployed in the cloud or even on-prem for that matter. So SRE is really important. And SRE really, when it comes to like availability, is absolutely critical to understand how your applications will respond. If you lose, if you have a cluster of, let's say, Kubernetes nodes, and you lose a node, what's going to happen? How do you respond to that? Having an SRE team to design the proper response to or solution to that problem is something that you might want to think about as well. What is the difference between DevOps and SRE? And again, the main focus is, again, SRE and DevOps have similarities, but the real difference is really, is it a top-down approach or is it not? So generally, SRE is more driven from the top. It's governed typically by the development team instead of the ops team generally. So it's about ensuring that the leadership is there and taking an active role. Because when it comes to software development, when it comes to designing services for your environment or for your cloud platform, the software team is really going to be the ones that should take the lead in that. Operations should be really more focused on keeping the day-to-day stuff going, not so much the design and pre-deployment activities in some respects. They should be involved, but not to the level that development should be. And here's a diagram that has a lot on it, but this is around K8s. So K8s being Kubernetes. And again, that's really more focused on how do we go into basically a deployment process and how are the workflows structured? How do we deploy our code? For example, are we using tools, for example, that are going to manage the configuration? Again, having tools like Terraform could be a huge deal. Or if you're using AWS, CloudFormation, or Google Cloud, for example, using Deployment Manager, using the right infrastructure as code tool is going to absolutely be critical here. We want to rule out mistakes. And the best way to do that is to template your deployment and ensure that this is done correctly the first time, and then have a repeatable process, and therefore we could repeat and repeat after without worrying about issues coming up by manually cutting and pasting something or writing adjustments to the code. That's really the goal. Now, we also need to have monitoring tools when you look at backup and restore. Surprisingly, a lot of organizations are really good at monitoring. They're really good at support, but they don't look at disaster recovery or backup and restore as seriously. And we also need to take into account, for example, our availability requirements. Basically, what is the downtime? What is the uptime requirements? And all of this really needs to be looked at significantly. Now, DevSecOps, as far as what that means, this is really what I call a subsection of development. This is where security, typically in DevOps, might be an afterthought. This is really where security in DevSecOps is a pre-thought. In other words, you think about security before you develop instead of developing and then security after. So it's all about the use case here, understanding the best processes. So DevSecOps is an approach that incorporates code testing, automating your builds, release software, adding security automation as well. For example, one thing that might be recommended nowadays, for sure, is preventing data breaches. One of the things you could do is automate DLP, automate your data loss prevention. Look for the social security numbers. Look for addresses. Look for, basically, depending on your country, look for any kind of privacy requirements that might actually expose your company to issues. So it's all about understanding the concerns. And the big one right now is GDPR, for example. So trying to figure out how you attend to that could be some good exercise to go through. Now, DevOps, when we consider DevOps, it's basically, again, plan, build, integrate, deploy, feedback, right? But when we go look at, for example, DevSecOps, there's a couple additional steps, and it's really added to the process. And one of the credits here is Larry Macarone, and he was the pretty much the documented, I guess, inventor of DevSecOps. He's the one that sort of put out the recommendations on it, the documentation as well. when it comes to best practices with DevOps, we want to go serverless whenever we can. We want to pay only when our code runs. We want to scale automatically. We want to run code in response to events. So we don't want to just run code to run code. We want to respond only if we need to. Using open formats will be very helpful. And also looking at services such as Firebase, Jenkins to help provide that. All right, so that's sort of a summary here of the defining terms and best practices at a high level, organizational structures we want to consider. Before I get into the top 12 here, I want to go ahead and minimize this. And let's go over to the Cloud Console. Now, I'm over in Google Cloud. Now, one of the recommendations that I have is to always try to use a service that is managed, because a lot of the security is going to be handled for you, or it's going to be provided to you as an option on how you handle your certificates, how you handle your snapshots, how you handle your deployment terms. A lot of things are there. However, if you're using this on-prem, this can also be beneficial to deploy as a DR solution, availability, testing, etc. So I'm over here at the Cloud Console, and I want to go over to the Kubernetes Engine. Now, what I want to do is create a cluster. And this is going to follow up with some of the best practices when it comes to what I'm going to talk about. So I'm going to go ahead and create a cluster here, and I'm going to call this the Quick Start Cluster. And I'm going to spell it right. How's that? Okay, Quick Start. Now, I need to consider, even in, of course, Kubernetes, whether I deploy this in the cloud or on-prem, I need to understand how I'm going to scale this, but also what is the cost structure as well. So when I select location type, it's going to be zonal or regional. If I go regional, I'm going to have this deployed in a region. Now, a region is basically a geographic area that has zones. Now, zones are virtual data centers. This is true basically in any cloud provider. The terminology might be slightly different, of course, but so if I do regional or if I do zonal, now regional, of course, is going to be somewhat more available than zonal, because if I deploy the cluster in a zone, that's basically only one part of the region. And if I go regional, again, I could select a specific region. Now, the minimum number of nodes you want to deploy as a best practice is, of course, 3. And just be aware, too, that when you deploy this, you could scale this up as needed. Select the right configuration. For the purposes of this demo, I won't talk a lot about the config. I'm just going to go move on. I do want to go over here to security, since we're going to focus on security today. Under security, there's going to be some areas that you want to take a look at. So for network security, we have, for example, do we want to deploy a private cluster? So a private cluster is exactly what it sounds like. It's only for you or for your department. No one else is going to be able to deploy services on it, etc. Now, if I do that, I need to specify, of course, what? An IP range. And then, for example, if I don't want to deploy a private cluster, I can enable what's called master authorized networks. So I could say, for example, only allow specific networks to access these resources. If they're on this network, they can go. If they're not, they can't. I could also create a network policy that adds more basically security-related areas like roles, etc. And then in security, I could issue, for example, basic authentication. Now, if I select basic authentication, this is going to require basically two-factor authentication. Now, there's going to be some changes with basically authentication and authorization. Just be aware down the road, this is always being added to and on the roadmap. I could also issue a client certificate. Now, I just want to point out this little note here. They don't recommend that you just issue a client certificate because of the fact that there's a rotation scheme that you typically want to use. One of the best practices is to rotate your certificates. And it's easy to forget if you just issue a certificate for that specific client. You don't want to really do that because you can forget to rotate that. Now, I could also enable shielded nodes. Now, shielded nodes is going to have different options for security around cryptography. Sort of a nice feature as well. And there's a lot of other nice features. Now, one thing that is coming up that I'm sort of excited about is customers that are using Google Groups can create a group just for their developers and just simply add them, and everyone in that group will inherit the same permissions. So that could be a nice feature. I could also add metadata. For example, metadata is data about data. Basically, if we're going to monitor or manage, I could go ahead and do that. By default, you probably want to enable monitoring. Now, be aware that there's different types of monitoring in Google Cloud and Stackdriver. I won't spend a lot of time on that for this demo. I did want to deploy an instance and take a quick look at it. And in the meantime, that's interesting. Okay, so looks like there's a, let me see, quota issue. That's interesting. And again, what happened here is you're only allowed to deploy services with so many virtual machines. And it's funny because I deleted everything and it's still locking up. Let me go ahead and deploy it in this project and quickly here. If not, we'll just move on. I didn't really plan on this. So you can see I'm going to start up the API. I didn't have this deployed in that project. So in Google Cloud, we use projects as a way to segment basically our resources. So while that's starting, let's go to a quick whiteboard here, and then I will get into the top 10 here, or top 12. Okay. Now, when we deploy our services, like I was stating, we want to deploy our services in a pipeline. And it's really about understanding the workflow and understanding, for example, that when I deploy, for example, from my code base, let's say in GitHub, or my other repository, whatever that may be, like cloud source repositories, I may want to ensure that I have a standard so that when my developers are adding, for example, basically their images, I'm able to go back over here and deploy everything in a consistent manner. And it's all about that consistency that really will help you when it comes to the security of the containers. So let's go back and see how we're doing here. And I'm going to go ahead and just leave it as a default, just quickly get started here. And that is in a different project, so that should not exceed any limits, even though there was no limit set. Sometimes strange things happen in the cloud. So that looks like it's deploying. I'll come back and we'll check on that in a few minutes. For time purposes, let's keep on, and then that way we'll have a cluster to walk you around a few things when that's ready. Okay. what are the 12 best practices? Now, this is a hard one. It wasn't exactly something that you could think about in an hour and just come up with, because there's literally hundreds of things that you need to do. Kubernetes is not a simple one-trick pony in the sense that there's so many features and functions and capabilities, extensions, APIs, other requirements to really consider. Now, so here's my top 12. Let's go ahead and get started. The first thing is to enable role-based access control, which is role-based security. Laziness is one of the things that typically will, what I call, create opportunities for vulnerabilities to exist and also to be exploited. So we want to think through, excuse me, got something there. We want to think through our enterprise's permissioning. We need to set up our users in groups, make sure that only developers are in the developer groups, production engineers are in another group, visitors, partners, whatever, auditors, all should be in their own group. We also don't want to enable cluster-wide permissions. Now, remember that with Kubernetes, we're deploying a namespace, and we need to be careful with how we deploy our cluster. We also need to realize and think about that everyone should be considered a guest. In other words, we just don't let them in right away. They should be on the guest list. Some of the commands that you want to look at would be cluster kubectl, get cluster role binding, and then also the all namespaces as well. So that's number 12. Number 11, we want to use namespaces to establish enterprise security boundaries. So what does that mean? Well, that means that when I deploy my workloads, not all workloads should be in the same namespace. Again, test, development, QA, compliance, we need to make sure that we deploy the appropriate workload in the right namespace. We could think of a namespace as a domain, for example, as another way to look at it if you're not familiar with that. We want to validate our namespace. We want to check out our namespace. For example, kubectl get namespace, get namespaces will list out the available namespaces and any of the pods that are in that namespace. Now, when it comes to number 10, we want to be able to validate, enhance our cluster node security. So if you think about it, we're focused on containers, but maybe we're not focused on the nodes, because the reality is that our containers have to run on nodes. That cluster needs nodes to run. Nodes are servers. That's really all they are. And in reality, servers can have lots of vulnerabilities. So we need to pay attention. Just some examples of the things that we want to do is to lock down the ports. If we don't need to have FTP open, don't leave it open. It shouldn't be open anyways. It's an insecure protocol. But just as an example, right? Think about it. If we don't want to have our developers SSH into the machine, we need to make sure that that's turned off. If it's if there's other ports such as UDP that don't need to be open, turn them off. We need to set limits and quotas. For example, we don't want to deploy more resources than we need, but also too, it could be that the attacker might want to spin up additional resources out on the fly and actually cause us issues like availability to the application. Number 9, we want to think about security around Kubernetes. Excuse me, one sec. Okay. My nose is getting itchy. Okay, so I think our cluster should be up. So let's hold off and go back, and our cluster is available. So again, now I want to go to the cluster, and I want to show a few things here. Now, one of the things that we want to consider is, of course, the version of Kubernetes we're deploying. Over here, this is the master version of the node that's deployed. We could also go over here and check the upgrade. So we may or may not want to upgrade our cluster. We want to think about that. And I'll talk about upgrading to the most recent version in a few minutes. And our cluster is now available. So I'm going to go back to that after I get to a couple points that I want to walk you through here. Now, number 9, audit logging. Okay, it's all about keeping track of who does what. If we're not keeping track of who is entering our building, for example, every time we walk into like our office, we may have a swipe badge. Well, that swipe badge, that access badge is probably logging somewhere. Same thing with what we're doing on Kubernetes. We got to log everything. We have to make sure whether someone tries to log in, they log in or not, then we have to keep track of it. Now, an access violation is what? This is going to be a violation where someone might not have the permission to do something and they try to do it. That probably is just a mistake on their part, probably not intentional, but we want to log it just in case. For example, if you have a developer that doesn't have deployment capabilities and it keeps on deploying for some reason, that's something that should give you a clue that there's some kind of issue there. It's a disconnect in the role, or maybe he's trying to do something he shouldn't be. Who really knows? Set up monitoring. We have to set up monitoring. One of the things about the cloud providers, if you are using Kubernetes on Google Cloud or AWS or Azure, they have really good monitoring capabilities built in that you could use as well. Or you could be using, of course, on-prem, any number of tools that you so choose as well. You know, whatever you're using, it's more than capable probably to handle what you need. Now, we want to identify credential creep. So what is this? Well, basically credential creep is where we give out, or not on purpose, but maybe because we don't understand what the role is supposed to do, more privileges than what they need. And here's the thing too. If we don't pay attention to that, we may not be noticing like APT issues as well. For example, if we have an application that is for some reason trying to SSH out at a certain time of day, every day, that might be something we need to look at. Or someone's trying to send out a zip file at certain times of the day. So logging is just going to really give you that important availability of understanding what's really going on. So we absolutely need to pay attention to that. Number 8. So number 8, metadata. So metadata is data about the data. Now, what I want to point out is metadata is handled a little differently by different providers or how you handle on-prem. And we want to use it not only to identify, for example, the type of traffic or the services being used, but we could use it for billing and also chargeback as well, depending on what we're doing. So the problem here is that metadata, if we don't set it up right and identify what we really need and what we don't, it could be exploited. I think about a year and a half ago, there was a case of where one of the containers was basically, what was called compromised. And being compromised, someone had apparently guessed some of the, basically was able to get past the certificate and was able to exploit the metadata of that configuration, and again was able to hack that company. I don't remember the company on top of my head, but these are vulnerabilities that are out there. And one of the best places to find out about vulnerabilities is the CVE list with CIS, and also CERT maintains a CVE as well. So that's a common vulnerability exploit list. Number 7. So number 7, we want to monitor our cloud native applications. It is a best practice. We really should monitor our environment. For example, if I go back to the console here, if I'm using Google Cloud or AWS, I could use any number of available services, or I could, in Google Cloud, it's really Stackdriver, but I could use a third-party service as well if I want to extend that out as well. So for example, if I go down to monitoring here, I then could go into the dashboard here, and it takes a second to come up here. And I want to then add that to the workspace. So in Stackdriver, I'm creating a workspace, which is a view of the resources. And what I could do is I want to collect the data on that cluster so that, well, that's spinning up, let's go over here. And if I go over here, what really is going on with Kubernetes Engine, it deploys the nodes on Compute Engine. And so there's 3 nodes that were deployed. So if I go back to my deployment over here under Kubernetes Engine, I could go, for example, into the cluster and actually look at the configuration, for example. And then if I want, I can also go and go look at permissions. And this is where I really want to pay attention to what services are deployable with Kubernetes. And again, this is not like a 5-minute project. You really want to think about this in deploying your services. I go to workloads here, and I deployed the cluster, but I need to deploy a workload on top of that. But if I go back over here to clusters, and again, I could go click on that cluster, I could connect to that cluster, and to do that, I could run that in Cloud Shell. So Cloud Shell is a basically in-browser CLI that I could use. And I'm now in that cluster there. So now what I could do is I could go look at the pods and all that as part of looking at what is available in the cluster. So that's just one of the things. But let's go back and check the monitoring. So the monitoring has started, and let's see, it did pick up instances. So let's see if it picked up those, and it has the cluster right here. Now you'll see that the data is not fully available. Some of this data you have to install agents on, but we actually installed the agents. So probably what happens is that it tells you right here, it could take up to an hour for this data to populate. But we can monitor our environment any number of ways. So it's really important to do that. Now, we want to create a network policy as well to automate as much as possible. We want to go ahead and make sure that we're paying attention to our environment. Okay, so let's go back to the presentation here. Okay, and that's it, yep. So if we're monitoring our applications, it's understanding not only do we have to monitor the cluster, but we have to monitor the hardware as well. And that's one of the things that in the cloud can be really easy if you use a managed service. So here's another thing. Abstraction. So what is an abstraction? So here's the way to look at an abstraction. We could think of like a node as a piece of hardware. And so the physical items is what? We have our network interface card, we have our memory, we have our CPU, we have the server, basically the other resources like the disk, etc. So those are not abstract. Those are actually physical, and they're not abstract. What's abstract is a virtualization. That's going to be in the world of containers, are pods or services or replicas. They're running on top of the physical hardware. And sometimes you might monitor the cluster, but if you're not maintaining your pods, your replicas, and everything as well, then those are areas that are commonly missed. And number 6. Okay, with number 6, it's about using managed services. For example, using a managed service with your Kubernetes Engine deployment will rule out about 30% of the likely security vulnerabilities that you might have on an on-prem deployment. Now, granted, you give up a lot of control of the physical hardware, but a lot of the back-end requirements is handled by the provider. So if you can make your life easier in that respect, then certainly do it. So the provider handles this maintenance, and that can be a big deal. Providers also have tools that can enhance your DevOps pipeline as well. So you may want to consider a hybrid deployment, for example, on-prem and the cloud. So why would we want to do that? For example, we may want to have our on-prem environment, but we may want to have a DR environment that is ready to go in the cloud. What we could do is I could go over here to Google Cloud, and I could go over to Deployment Manager, and same thing in AWS or Azure. In AWS, I could use CloudFormation. What I want to do is I could go over here once I enable that API. And actually, for time purposes, let me go to this project because I already had a deployment there. And under this deployment here, I already deleted it. So let me, Oh, no, there it is. Okay. And I did have one deployment. So what I could do is I could create a deployment and have it ready to go. And then if there's an issue with my on-prem environment, I could just simply go over here and click that, and I could deploy that solution as needed. And again, it's all about the use case, it's about using what's available to you. And again, it's really up to me. So I can create a deployment and deploy it. Number 5, how are we doing on time? Okay, we're right on time. So here's one of the challenges is preventing kubelet from changing labels. So one of the things we don't want to do is, again, it's all about making sure that the API can't do any more than it should and having the right restrictions in place. So we want to set up node restrictions. And there's also a plugin here that you look at called Node Authorizer. This is going to add that extra layer of security to your deployment. So it's basically an authorization mode. Now there's another mode, there's a couple other options you could use as well. Binary mode is more for when you deploy your services per se. This is more for your API. So again, it's sort of like a different scenario that you might want to use this under. But this is an area that sometimes people overlook. Number 4, there's a new resource available in Kubernetes 1.8 called Ephemeral Storage. So you could use ephemeral storage for local storage. On the other hand, you need to look at the resource and limits on it. And if you do a kubectl describe, this will tell you if that is available or not. So you want to pay attention to that as well. Number 3. Now, snapshots are, of course, something that typically most environments are already doing. It's really about, are you really looking at the correct number of snapshots? And are you looking at how you handle the backups of your snapshots? But also how the disaster recovery is handled. Now, there's a really nice link here I'd recommend you take a look at that goes into the number of snapshots. Now, by default, the limit is 100,000. It's a lot. But on the other hand, if you have a large Kubernetes deployment, it wouldn't be the first time that that can come close to being exceeded, especially if you're keeping your snapshots for a good amount of time. So one of the things you want to do too is make sure you have dedicated hardware for your for maintaining your snapshots, because etcd, for example, is really about performance, stability, and security. The last thing we want to do is basically restrict etcd in any way, because etcd is really where performance, stability, and security really come into play. And again, that's another discussion itself. Number 2, high availability. Again, make sure you read the best practices. Make sure you know the requirements. For example, minimum number of 3 nodes is recommended, for example. So have a minimum number of 3 master nodes across multiple zones. Now, for example, if I go back over here, go over here. What I could do and give that a second to come up. Okay, there it is. So for example, if I'm designing my Kubernetes cluster, let's say I have my on-prem services there, and then I want to have either another site, whether it's on my company site or in the cloud. So for example, I may have a DR site, and I might have, maybe I'm using, instead of a DR site, a cloud service like GCP or AWS. And then here is my on-prem deployment. Now, what I want to think about is this. I need to make sure, for example, that my nodes are deployed, and when I go into, for example, Kubernetes here, I need to consider, for example, here, let me minimize that, and that's in the other project. I may need to look at storage, and I may need to have a persistent volume, but I also need to look at, for example, the type of storage that I keep my snapshots on. But when it comes to my nodes, I need to go over here to the cluster, look at my cluster, and actually, for example, look at the nodes, for example, over here. You can see I have my 3 nodes. This tells me the amount of memory, the allocation, etc. And then again, I could add a node pool. And when I do that, again, when I add that node pool, I want to pay attention to the recommended version. The master version is there. I could enable auto scaling. I didn't have time to talk about that, unfortunately. But then I could go over here and look at my config and change that as needed. This is where I want to also change my disk if I want. I can also, now, I don't want to enable preemptible nodes in production. Preemptible means that you're using a node from Google Cloud that is only available no more than 24 hours. It's sort of like a spot instance in AWS. Then I could go over here and, of course, set up my networking, my instance metadata. So remember we talked about metadata? I want to, of course, pay attention to the metadata that I add, because this metadata could actually be breached if someone was able to breach my containers as well. And over here are labels. So there's a lot of things to consider here just on your nodes. Now, what about memory optimization? Now, memory optimization is going to give me more memory and actually be more focused, probably more on performance when it comes to queries or any kind of workload that might look at memory intensive requirements. And that could be like a search, it could be a query, whatever that is, but it's going to use a lot of memory generally. That's going to be a use case for that. So these are just some of the things that you want to look at. And then over here, when I get my workloads deployed, I'd want to go over here and actually deploy the workloads based on requirements. And then services, this is where I want to perform load balancing, and this is something that is available in most of the cloud services at different levels, so you want to really understand how that works. And again, a lot more to talk about here, but let's go ahead and close up here. Number one, what is the number one security best practice that we really want to look at? It's training, okay? It's about getting the training that you need to perform the job. Now, Quick Start, of course, has numerous trainings available. If we go over here to Quick Start, we simply type in, for example, Kubernetes, and you could see, for example, that there's introduction to Kubernetes and Docker, Kubernetes for developers, Kubernetes administration, fundamentals, and then again, those are just some of the courses. And again, these are just Kubernetes focused. And then again, if we're talking about containers or development, we may want to look at DevOps. And again, there's a lot more available there on the different platforms out there. So it's really about knowing where to go. Now, also too, I'd recommend you go over here to Kubernetes, and we want to go over here to CVE. So there is a common vulnerability for enterprise list security bulletins that you can go to. Different providers have them. So this is, for example, Kubernetes, the CVE. These are a list of all the vulnerabilities that have been documented, and there is quite a bit. Contrary to what people might say, containers are not really secure by nature. They're meant to be easy and lightweight to deploy, but generally not secure. So it's really up to your team to be able to go out there and deploy your Kubernetes clusters, your pods, your applications and services in a secure manner, in a manner that is done by best practices that can mitigate these vulnerabilities that are commonly out there. And there's tons of new resources coming out every day. I would encourage you to look at some of the courses available, also to other webinars that might be available. There's also free resources that are also available, I think, by the Linux Foundation as well, that you may want to look at. With that said, I'd like to close it out. If there's any questions, please do speak up and let me know. So when it comes to putting it all together, DevOps, SRE, and cloud native, we have to work on all these best practices to provide our enterprises the ability to have a secure, well-performing container environment. It really is important to deploy our resources in a manner that attends to best practices. We want to understand Kubernetes security is complex. There's thousands of variables that could go wrong, and all you need is one variable to be missed to have yourself in the news headlines. And we don't want that. And again, we want to make sure that you're aware that it's complex. You need to take your time planning it, get trained, learn everything you can. And again, think of security before you deploy your containers. DevSecOps should be a pre-thought, not a forethought. And again, remember the 12 best practices. If you go look to your favorite search engine, there's at least 100 plus more that are out there that people list. Plenty of good ones out there, not an exclusive list by any means. So I definitely encourage you to learn more. With that said, I'd love to turn it over to the moderators. If there's any questions I can help with, please let me know.
Yes. There isn't any questions because
sure,
there weren't any people.
Okay.
So
I wasn't sure. I just figured I'd ask. Okay.
No, I just like to apologize for this. I don't know what marketing is doing. They're changing a lot of things around.
Oh, okay.
Like I said on my email, the things going on. And today, even they didn't send you the link. They didn't send you the logins, and I don't know.
No, I asked for it 2 days ago.
Yeah. So I'm really sorry about this. So one of the things from this webinar, you were discussing about data loss prevention.
Yes.
So can we do a webinar around data loss prevention in the cloud?
Oh yeah, absolutely. Yeah, I could do AWS or Google, for example. If I go to Google, I give you an idea of what we could talk about, how we could approach it.
Yeah.
So. And again, I could do, for example, a webinar on Google Cloud or AWS or Azure, whatever makes sense. Yeah. I could do like a generic one that I talk about, the major 3 providers. That might provide, I think, more of an audience, hopefully. And so if I go over here, I go to data loss prevention. And there's just several things we could look at, for example.